Hey there, physics students. So our first unit here in physics is about measurement. We're going to talk about measurement. We're going to learn about the SI system of units. We're going to do that in the next lesson. Okay. In this lesson today, we need a little mathematical tool in our toolbox to help us to understand the next lesson. So in this lesson today, you've probably worked with this in the past, but we're going to talk a little bit about it, make sure everybody remembers and is up to speed on scientific notation. So our target that we're working on is to be able to use the SI system of measurement. What we're going to do first is we're going to talk about the scientific notation. So let's go ahead and let's talk about scientific notation, do a couple of problems, get that out of the way. Alright, so sometimes in science we deal with numbers that are huge, or we deal with numbers that are extremely small, right? If I'm talking about the mass of an electron, the mass of an electron is tiny. It's this infinitesimal amount, right? This tiny amount. The mass of an electron is going to be like 0.0000, I think like 19 zeros to this number, right? Number of kilograms. If I'm talking about the mass of the sun is enormous in kilograms, right? It would be I think it's 2 times 10 to the 30th, so it'd be like a 2 followed by 30 zeros, right? These are incredibly large or incredibly small numbers that are just not convenient to express as a standard number, right? So sometimes what we will do is we will write them in what's called scientific notation. And a number that's in scientific notation will look like this, okay? It would be something times 10 to the something. It's always 10. It's always times 10. That's what scientific notation looks like. Something times 10 to the something. Okay, this something, this first thing, this number here, must be a number between 1 and 10. Okay, it's always got to be between 1 and 10. It can't be 0 point something. It can't be 10 point something. It's always got to be some digit, a one-digit number, point something else. It's got to be between 1 and 10. Right? And then it's always times 10, and then the exponent up here, this number up here, is going to be the number of places that you've moved your decimal point to the left. Okay, so let's think about a number like, I don't know, how about 210? How would we express this in scientific notation? Right. Well, first, let's say we got to ask ourselves, well, where's our decimal point? And our decimal point in this number is right here at the end. If you don't see a decimal point in a number, you know where it's at the end, right? So here's our decimal point. How can we move that decimal point so that this number will be a number between 1 and 10? Well, if I move this decimal point a couple places over this way, so that it's right here between the 2 and the 1, then I have a number that's between 1 and 10. Now it's going to be 2.1. 0.1 is between 1 and 10, right? And then it's always times 10. And then I ask myself, for the exponent, how many places left did my decimal point move? And you can see it moved 2 places to the left. 2 places to the left. So I will put a 2 right there. If the decimal point moved to the right, we'll say it moved a negative number of places to the left. So if I'd had to move it this way, then I would have had a negative number there, right? So you can see this number in scientific notation would be 2.1 times 10 to the 2. Now, with a number like that, it's probably just easier to write 210. But if we have a much larger number, then it might be much more convenient to write the scientific notation. If you see one where maybe we have to move the decimal the other way, let's say we have 0.00000001. Okay. Now here's a number that would be a pain to write over and over if you're doing math with it, if you're doing a calculation. So here's a number that you would probably want to use in scientific notation. Let's take a look. How can we write this in scientific notation? Okay. Well, I need the first part of it to be a number between 1 and 10. So where can I move that decimal point so that it's between 1 and 10? I'm going to move it all the way over to here, right? So that I end up with Okay? And then it's always times 10. And then ask myself, how many places to the left did I move that decimal point? Well, I didn't move it left, I moved it right. So since I moved it right, I'll say I moved it a negative number of places to the left. So how many places is that? 1, 2, 3, 4, 5, 6, 7, 8, 9 places I moved the decimal point to the right. So I'm going to make it a negative 9. So that number would be 3.1 times 10 to the negative 9, which is a lot easier to write over and over when I'm doing a calculation than 0.0, keeping track of all the zeros. The exponent keeps track of how many zeros for us, so that we can just worry about doing the math and not making sure we wrote down all of the zeros. So that's what scientific notation looks like. Sometimes you want to go the other way. Sometimes you have a number that's in scientific notation, and you want to say, what is that number in a standard notation? So you want to take it out of scientific notation. Well, how can we do that? Let's take a look at it. So here I have the number 4.16 times 10 to the 5th. Okay. Well, what that tells me, that 5 tells me, is that we moved our decimal point 5 places to the left. So to take it out, I want to move it 5 places to the right. So I have 4, and then the point is going to move to the right. So it's going to move 5 places now. So it's going to move 1, 2, 3, 4, 5. And these empty places, I'm going to put zeros to fill the places. So 3, 4, 5. So it was here. Now I've moved it 1, 2, 3, 4, 5 places. Now it's here. So now that number that we had there, put a little comma in there to separate the zeros, and we have 416,000 is what that number is. Maybe I had a number like, I don't know, say it was 2.13 times 10 to the negative second power. And we want to know what is that in standard notation. Okay. Well, our decimal point was here, and it was moved 2 places. It was moved negative 2 places to the left, which means it was moved 2 places to the right, which means to take it out, let's move it 2 places to the left. So I'm going to move it this way, right? 2 places. So I'm going to move it here, and then to fill in that other space, we're going to put a 0. 0, 2, 1, 3, and my decimal point over there. It started out here, I moved it 2 places to the left, and now it's here. And I could put a 0 in front just to kind of 0 point something, right? So that number would be 0.0213. Now sometimes after doing the calculation, you end up in a place where it doesn't really make sense to have the number in scientific notation. Let's say I do a whole calculation and I end up with 2.1 times 10 to the 1. I could write that for my answer, and that'll be fine. But to look at that and understand that that number is 21, and to just put 21 as your answer is a little bit more convenient sometimes, right? So sometimes having the number in standard notation is more convenient. Sometimes having the number in scientific notation is more convenient. In general, when you're doing a physics problem, you should generally answer things the same way that you were given things in the problem. So if the problem gave you a bunch of numbers in scientific notation, you should give your answer in scientific notation. If it gave you numbers in standard notation, you should give your answer in standard notation. Unless it becomes inconvenient to write that number in standard notation, then write it in scientific notation. Okay, so here is the kind of problem that we're going to be asked to do on our assignment, right? Here's 4 different problems. They're asking us to write these numbers in scientific notation. So let's go ahead and take a look at it. What would those be? So the first one up there, 12.1. How would I write this number in scientific notation? Well, I need to move that decimal point so that it is a number between 1 and 10. So where can I move the decimal point to make it a number between 1 and 10? Well, I can take that decimal point and I can move it right here. If I moved it right here, that number will become 1.21, okay, which is between 1 and 10. And then it's always times 10. And then what number do I need for my exponent? Well, it's how many places did I move my decimal point left. started here, it ended up here, I moved it one place to the left. So one place to the left would be 1. So 12.1 is 1.21 times 10 to the first power. The second problem up there is 0.0023. Where should I move my decimal point to? Well, I should move my decimal point to this place right here between the 2 and the 3. Because 2.3 is between 1 and 10. Okay? And then it's always times 10. And how many places did I move my decimal point left? Well, I didn't move it left, I moved it right. Right, 1, 2, 3 places. So since it moved right, we're going to say it moved -3 places to the left. Right? So, 0.0023 is 2.3 times 10 to the -3rd. The third one up there is just the number 50. Okay. Where can I move the decimal point to? Well, right now, ask ourselves, where does the decimal point start at? It starts at the end of the number. If we don't see a decimal point, we understand it's at the end of the number, right? So where can I move it to make it between 1 and 10? Move it to right here. That would give me 5. 5.0 is 5. And that's between 1 and 10. And always times 10. How many places did I move the decimal to the left? I moved it just one place. Here to here, one place. So 50 is 5 times 10 to the first power. And the last one of the example problems is 0.03. Okay. Where can I move the decimal point so that it's between 1 and 10? I can move that decimal point right here. And then the number I have is 3. It's always times 10. And then how many places did I move my decimal point to the left? Well, I moved it 2 places to the right. So we'll make it a -2. So there we go. It's 3 times 10 to the -2nd power. There's a few examples of how we put numbers into scientific notation. Okay, in addition to putting numbers into and taking them out of scientific notation, we will also want to be able to do some arithmetic with numbers in scientific notation. So we might want to add or subtract or multiply or divide these numbers, right? We will much more often than not multiply and divide them than add and subtract them, but being able to add and subtract them is still important. Consider what I have up here, right? I have 2 times 10 to the 2nd power plus 2 times 10 to the 2nd power. How do I add these numbers together? Okay. Well, first of all, when I write out some numbers that have scientific notation, and what I often like to do, because it looks a little bit confusing, is I like to put parentheses around the scientific notation numbers. So I know what I'm doing is 2 times 10 to the 2nd plus 2 times 10 to the 2nd. It makes it a little bit more clear to me when I look at that. So I like to put parentheses around the scientific notation numbers. Okay. Secondly, when I add or subtract numbers in scientific notation, they must have the same exponent. If they don't have the same exponent, I can't add or subtract them. Okay. So if I have 2 times 10 to the 2nd and 2 times 10 to the 2nd, they both have the same exponent, which is good, which means I can add them. Okay. So to add them, what I'm going to do is I'm just going to add the number parts, and I'm going to keep the same exponent. Okay. So I have 2 plus 2, which is 4, and I'm going to keep the same exponent. So 10 to the 2, 2. Think about it as if you were adding 2x plus 2x. It would be 4x, right? You wouldn't mess with the x at all. It just stays there. And it's the same thing here. So 10 to the 2 and 10 to the 2, it stays 10 to the 2. When you're adding or subtracting, if you're subtracting, it's the same. You just subtract the 2 numbers instead of add them, right? Now, what if those 2 exponents are not the same? Let's say instead, I had a 10 to the 1 here. So I have 2 times 10 to the 2 plus 2 times 10 to the 1. Okay? I can't add those the way that they are. So I mean, you can add these numbers together, but you can't add them together the way that they are. There's a couple of strategies you might take, okay? First, you might just take the numbers out of scientific notation. And in that case, here I have 200, and here I have 20. So that becomes easy, and it's 220, right? And then you can put it back into scientific notation. And back into scientific notation, you have 2.2 times 10 to the 2, right? The other strategy you can take is to make the exponents the same. And this will involve one of the numbers not being in proper scientific notation. So what I can do is I can leave this number as it is, and then I can change this number by moving the decimal point one place to make this a 10 to the 2. See, I want it to be 10 to the 2. I can move it one more place to make it a 10 to the 2, which will make it 0.2 times 10 to the 2. Now, is that proper scientific notation? No, because this number is supposed to be between 1 and 10. It's not. But writing it like this helps me add them together. So I'll end up with 2 plus 0.2, which is 2.2, and these are both 10 to 2. So that's adding and subtracting numbers that are in scientific notation. Subtraction is exactly the same. Okay, now let's talk about multiplying and dividing numbers that are in scientific notation. Okay, when you multiply or divide, we're not going to keep the same exponent, so the exponents don't have to be the same. Okay, so you can see here I have 5.1 times 10 to the 2 times 2 times 10 to the 3rd. The exponents are not the same, but that doesn't matter because we're going to multiply. Okay, when you multiply these numbers, first you want to multiply the number parts. So I'm going to take the 5.1 times the 2, and I get 5.1 times 2 is 10.2. Okay, and then I'm going to bring the times 10. And the rule for exponents is when you multiply them, you add the exponents. So they have to have the same base, and of course they always should, because the base is always 10, right? But then we'll just add the exponents. So 10 to the 2 times 10 to the 3, 2 plus 3 is 5, so that would be 10 to the 5. Okay. Now, you gotta be careful when you multiply, because a lot of times when you multiply, you get a number bigger than 10. Remember, this number must be between 1 and 10. Is this number between 1 and 10? No, this number is bigger than 10. So what I'm gonna do is I'm gonna adjust the decimal point, okay? I'm going to take that decimal point and I'm going to move it so that this number is between 1 and 10. I'll move it right here. So this will be 1.02. Okay. Now this says that the decimal point's already been moved left 5 times, and I just moved it left 1 more time. So now what's the exponent going to be? It's going to be 6, because that decimal point's been moved left 6 times. So when you multiply some numbers in scientific notation, be careful. Look at your answer, make sure it's between 1 and 10. If it's not between 1 and 10, you'll have to adjust it. You get a similar problem when you divide. Let's take a look at that. Okay, here's some numbers being divided. I have 3 times 10 to the 4th divided by 6 times 10 to the 2. So let's divide these numbers, and there's another thing we have to watch out for. Okay? So first I'm going to divide the number parts. 3 divided by 6, which is 0.5. 3 over 6 is 1/2, so 0.5. Okay? And then when you divide, what we're going to do is we're going to subtract our exponents. So we have 4 minus 2, which is 2. Okay? But now we have to watch out for something else. You remember with the last problem we ended up with a number that was more than 10 and we had to adjust the decimal point. Here we end up with a number that's less than 1, so we have to adjust the decimal point. Okay? So I'm going to move the decimal point right over here. So instead of being 0.5, it's going to be 5, because that's between 1 and 10. Okay? Now I have just moved this decimal point one place to the right. This tells me that the decimal point had been moved 2 places to the left. So where is it now? It's 2 left, 1 right. It's going to make 1 right. So we'll have to subtract 1 from this exponent here. So it'll be 10 to the first power. So instead of 0.5 times 10 to the 2, I'm going to write 5 times 10 to the 1. And in fact, that you could just write 50 would probably be more convenient. But you know, as we're working with scientific notation, give your answer in scientific notation. Right? So watch out. Be careful for numbers. If you're dividing, be careful for numbers that come out less than 1. You'll have to adjust it so that it's between 1 and 10. Okay, so we've done a couple of examples about how to work with scientific notation here. There's just a couple other things I want to mention, a couple of issues to keep your eye out for when you're using a calculator. Okay, first, the calculators that I have in the classroom, if you can see, they do have scientific notation. You can see on there it says 3 times 10 to the 50, and it actually says 10, 3 times 10 to the 50. It makes that times 10 very small, but you can still look at that and understand that that's your scientific notation, 3 times 10 to the 50. But on some other calculators, particularly some of the fancier calculators, you won't see that times 10 on there. Instead, they'll have that replaced with just an E. So instead of saying 3 times 10 to the 50 like that, it'll say 3E 50, something like this. And what that means, that is just the same as the times 10, and then this is the exponent. So particularly if you have some of these other calculators, if you're bringing your own calculator to class and you see this pop up on your calculator, that's what that means. This is the scientific notation, just like we've learned about. It's just the calculator can't display an exponent, so it's putting it like this instead. The other thing to watch out for is what I call the division issue. Okay, now I've put into my calculator here, I've put 3 times 10 to the 2 divided by 3 times 10 to the 2. It's the same number divided by itself. It should give me 1, right? But if you take a look, it gives me 10,000. Right? What's going on there? Why doesn't it give me the right answer? I put 3 times 10 to the 2 divided by 3 times 10 to the 2. A number divided by itself should give you 1, right? Well, let me show you what I put in and why it's an issue. This is what I typed into my calculator. So what my calculator is going to do, first, it's going to do 3 times. It's going to follow the order of operations, right? It's going to do multiplication and division at the same time from left to right. So it's going to do 3 times 10 to the 2, and 300, and then it's going to do 300 divided by 3, and get 100. And it's going to do 100 times 10 to the 2 and get 10,000. Okay. But this is not what I meant for it to do, right? I did not meant for it to multiply this 10 to the 2. I meant for it to do this. 3 times 10 to the 2 divided by 3 times 10 to the 2, right? So now if I go back and I put in my calculator like this with the parentheses around the numbers that are in scientific notation, it will in fact give me what I expected. It'll give me 1. Bear with me while I type on the calculator really fast. Now with those parentheses in place, it does in fact give you what you expected. It gives you 1. So if you're using a calculator to work with scientific notation, be careful. If you're not using one of my calculators, be careful of that E. And if you are using one of my calculators, be careful of that division issue. When you put in a number that's in scientific notation, especially if you've divided a number that's in scientific notation, make sure you put parentheses around it. Otherwise, it's going to mistake what you want it to do. So there is a little bit about scientific notation. We've done a couple examples, talked about how to multiply and divide and add and subtract in scientific notation. That's going to take us one step closer to being able to use the SI system of measurement, which we'll talk more about next time. So until then, take it easy.